Just like all classic problems in computer science, we are motivated by a real-world scenario. This alien has kidnapped you. He needs you to solve a problem with your skills, or else he'll probe you. The problem is, given a set of infinite lines, determine how many pairwise intersections there are. A line, of course, is defined by two distinct points along it. This is not the only way to define the line, but this is the format which the alien is using. You are given a list of these infinite lines, and you need to output just the count of the number of intersections, and you need to do it very efficiently. You have 10 minutes to solve this problem. You can pause now, but I will be counting. So in the simplest case, how do we solve this problem with just two of these infinite lines? Well, as we know, just like theoretical physics and useful applications, two parallel lines will never meet. So with only two infinite lines, such as these two here, we just need to check whether or not they're parallel. Alright, so normally how you check if two lines are parallel is by checking if they have equal slopes. But we don't have any guarantees about the pairs of points for each line. So we don't know if they're the same distance apart, we don't know if the lines are vertical, we don't know anything like that. So we need to somehow get the slopes out of this information. Just as a reminder, when we compute the slopes, we do it just by calculating the rise over run. However, since some of the lines can be vertical, instead of computing the fraction, the rise over the run, we compute the ratio of the rise to the run. We want to compute the ratio of the rise and the run. To do that, we first need to compute the rise and the run. That's quite simple. We just take the 2 points that represent our line, we take the difference between the x-coordinates and the difference between our y-coordinates. Those respectively give us the run and the rise. Then, we need to put them into a comparable form for other slope ratios, so we need to reduce the ratio. In order to do this, we take the greatest common denominator of these two values that we just computed, and we take each of the values and divide them by the greatest common denominator. And then we return the ratio. That gives us our slope ratio. We can use this to check whether or not a line is parallel with another line. To finally solve the problem and count the number of line intersections, start by setting our counter count to be equal to 0, iterate through the lines, iterate through the lines that occur after whatever the current line is in the list, and this allows us to iterate through all the pairs of lines, and then check if the slope ratios between the current pair of lines is unequal. Since the slope ratios are in reduced form, this is equivalent to checking whether or not the two lines have different slopes. That is, they are not parallel and therefore will have exactly one intersection between them. If that is the case, increment the counter of intersections, and finally return the number of intersections. The complexity of this solution is quite easy to compute. We are iterating through all pairs of lines. Asymptotically, this is a quadratic number of iterations. Within each iteration, we are performing more or less constant work. The only operation within each iteration that is not constant work is the call to the greatest common denominator function. While non-constant, the runtime of this function is negligible in practice, and hence the runtime of the solution overall is more or less quadratic. This is actually non-optimal for this problem. Watch my next video to find out how to escape the aliens once and for all.